Bless you. Okay, section 6.3, dividing polynomials. So we reviewed quickly before long division, because that's what we'll be using. So because we already reviewed it, I'm going to dive right into example 1. Divide x squared plus 3x minus 12 by x minus 3. X squared plus 3x minus 12. And we're going to divide it by x minus 3. So just for the sake of like other stuff we're going to talk about, you could write it like this: x squared plus 3x minus 12 all over x minus 3 is one way to do it. And but we're not gonna, so this is just like a fraction. If you're saying like 4 over 3, you're saying 4 divided by 3, right? Yeah?
Yeah.
So the top number, the numerator, is the dividend. That's what you're dividing. And the bottom number, the denominator, is also called the divisor right here, right? So if we write what we're dividing in the swoopy thing, as Christian likes to call it, I would have x squared plus 3x minus 12 in my swoop, not a square root, and then dividing it by x minus 3. So just like when we were doing long division, you need to kind of ask yourself, what do you need to multiply this here, this x term by to get to x squared?
By x.
Yeah, you need to multiply by x, so the x goes up here. And then just like with long division, then we're going to do, so we do division, then multiply. Yeah. Then we're going to subtract, and then we're going to bring down. Those are the steps that we're going to follow. So we did the division. We're going to multiply now. So x times x is x squared minus 3x. And then I'm going to subtract the whole thing. So you have to watch that part because this negative will go to each part in here, right? So x squared minus x squared.
Wait, where's your negative going?
It's being distributed to everything in the parentheses.
I cannot see upside down across the table.
Okay. So just like when we were subtracting before, we were subtracting, let's say we were doing something like, I don't know, 3 fits into, no, I have to do like 31 fits into 97. If you did this, you'd say it fits in 3 times 31 is 93. You're subtracting all of it. You're subtracting the tens and you're subtracting the ones. That's similar over here. We're subtracting the x squared parts and the x's. But you have to be careful because there is already a subtraction in there, but you're subtracting a negative, which means you're actually adding, right? The first two cancel out. X squared minus x squared is 0. You don't have to write the 0. I'm just emphasizing that it's there. Then I have 3x minus negative 3x. Well, yeah, so it's going to be a positive 6x. And then you need to bring down the negative 12. Then we ask ourselves again, what do you have to multiply x by to get the 6x?
You have to multiply it by 6.
You're going to multiply it by 6, so we're going to put the, and it's going to be a positive 6 there. And then we do again the multiplying. So 6 times x is 6x, which it better be. You want those two first terms right here to look the same because you want them to cancel out. And then 6 times negative 3 is negative 18.
Negative 3.
Right here.
Oh, you times it.
Yep. I'm going to erase some of these arrows so that it just cleans it up a little bit because you don't need all these.
So take that away, and so then you have negative.
So then remember, I'm subtracting
30.
this whole thing, right?
So then you have negative 30.
No.
Your 6x's are gone.
Because, so remember that
it's plus.
this becomes, so if I say this is distributed, this is a negative, this is a positive.
Negative 18, so it's plus. So it's 6.
It's 6 here, right? And those two cancel out. So I'm left with 6, right? So I have a remainder of 6.
Yeah.
So you can say that the quotient or the answer is x plus 6 with a remainder of 6.
X plus 6 with a remainder of 6.
So that's your entire answer. So if you're looking in your book and your homework stuff, you would see something written like this. We talked the other day about another way to show remainders is to say that that's the portion left over your divisor. So you could also write it as x plus 6 plus, because the 6 was positive, 6 over x minus 3. This is the remainder portion. Simply for example 1, we're saying this way with R. The old school, like when you were first learning division way back in elementary school, you'd use remainder, whatever. 17, remainder 3.
Why don't I remember the remainder at all?
Yeah, I
Because
don't remember that
You
part.
didn't use it for very
Very well.
long because you then learned decimals. And you don't have to have a remainder. You could continue
Oh.
dividing. That's why. Okay, how could you check your answer?
By
Put it back
putting,
in.
But what do you mean by plugging it back in?
Put it next to the.
So if I had something like this one over here that I started doing that I didn't actually finish, I would have had 4 left over. So I would have had, with this one, 3 remainder 4. How would I check that 3 remainder 4 is the answer to 97 divided by 31? How do I
you
check
put that
it?
in the calculator.
No. Goofball. What would you do?
Multiply
Multiply what?
the. I don't know where are they?
We're looking right here.
31 times 3.
Right, so I'd say 31 times 3 first. 31 times 3 is 93. So then I'd have,
remainder.
so I'm making this really messy. 97 divided by 31 is 3 remainder 4. So Hannah's saying to check it, you'd say 4, 4,
3 times 31
right.
is 93.
3 times 31, which is 93. But that doesn't get me to the 97.
You have remainder
97
4.
minus that, and it should be the remainder 4.
Hold on. So what can I do with the remainder 4?
Plus
Not
add it onto it.
yeah. So I can say
It's just the opposite of
93. Exactly, it's the opposite. 93 plus 4 would give you the 97, which is what I started with. So we could do the same thing with this big complex polynomial. I could say, to check it, you can say your answer, x plus 6, times your divisor, x minus 3, then you're going to add your remainder, plus 6. So with this first part here, you need to FOIL. X times x squared. X times negative 3, negative 3x. 6 times x, plus 6x. 6 times negative 3, negative 18, plus 6 still from right there. If I combine like terms, those two and those two, I would end up with x squared plus 3x minus 12.
Wow.
And that's what I had up in the beginning. So you can check this work. I'm not saying you always have to, but if you're like, oh, it doesn't, I don't know if that makes sense, you can check it instead of just redoing it. All right, example 2. Determine whether x plus 4 is a factor of each polynomial.
Oh, so just do x plus 4 times. Okay.
Divide it into them. Yeah, exactly. Determine whether x plus 4, I'm putting in parentheses, your book is not, is a factor of each polynomial. Sorry. So you got the first one of x squared plus 6x plus 8, and then the second one is x to the third plus 3x squared minus 6x minus 7. So we're going to set those up as division, right? To see if it actually works out evenly. In other words, no remainder.
Are we just doing all of A first?
Yeah, we'll do all of A first. So I'm going to set up the swoopy thing. X squared plus 6x plus 8, dividing it by x plus 4. What do you need to multiply x by to get to x squared, right? Then you multiply that. What do you end up with?
X squared plus 4x.
X squared plus 4x. And I'm going to subtract all of that. Pardon me. So I have nothing left there. And 6x minus 4x would give you 2x. Bring down the 8, and it's positive. What do you have to multiply the 2x by to get to? Sorry, what do you have to multiply the x by to get to 2x?
2.
Yep, so it's a plus 2. 2,
Wait,
what?
Where did you figure
What do I have to multiply this divisor by to get to the dividend?
Oh.
It's the positive 2. 2 times x
2
is
times 4
2x. 2 times 4 is plus 8. When I subtract all of
You get
that,
0.
right, you get 0. There's no remainder. So is what we started with,
There's
x
no
plus
remainder,
4,
it's
is it a factor
yes,
then?
it is.
So yes. X plus 4 is a factor. It divided it evenly, no remainder. I'm sure you can predict what the part B will be.
No, it is
Right.
not a factor.
But it's good practice as far as the dividing, because we've never done one so far with an x to the third in there. X to the third plus 3x squared minus 6x minus 7. Still being divided by x plus 4. So you ask yourself, what do you need to multiply x by to get to x to the third?
I mean, x squared.
Uh-huh, say it.
X squared?
Yes, x squared. X squared times x would give you x to the third. And then x squared times 4. would be-
4x squared.
Yep, and it's positive 4x squared. I'm subtracting all of that. I'm going to keep emphasizing all of that because that's where most commonly where the mistakes are made. So the first two terms cancel. X to the third minus x to the third is 0. 3x squared minus 4x squared is a negative x squared. Right?
Plus 6x minus 7.
Right? So, no, not plus. It was
Take
minus,
away.
minus 6x minus
Oh,
7.
it was minus.
So I'm going to bring everything down so it doesn't get lost. Man. What do you have to multiply negative x squared by to get, sorry, what do you have to multiply x by to get to negative x squared?
Negative
Negative what?
x.
Nope. Oh, sorry, yes, negative x. I apologize. Negative x. I was thinking negative 1. So then negative x, let me get rid of these arrows. Negative x times x is your negative x squared. Negative x times 4 is negative 4x. I'm subtracting all of that
Wait, it's in the bubble, it's negative x
squared
squared.
minus 4x.
All of a sudden just clicked and now it's like really easy. Like,
Good.
Yeah, I remember
That's, this is kind of why I know you already know this is not going to be an even factor just because that's the way this book does A and B. One's true, one's not. Because there are. We're going to change it and we're going to make it even easier in a minute.
Wait,
So now that you understand this, wonderful. We're going to do it. What's that?
We didn't finish it.
I know we're not finished.
Oh.
They're jumping ahead. Negative x squared
Example
minus
4.
x squared, 0. Negative 6x minus negative 4.
It's plus.
Right. Right? So then negative 6x plus 4x is a negative 2x. Bring down the negative 7. Notice that we didn't use the negative 7 yet. So you don't always have to bring everything down, but so that you don't forget it, I would recommend you keep bringing down what's left. All right, what do you have to multiply x by to get to negative 2x?
2. Negative.
Negative 2, right.
So we have minus negative 2.
Just minus 2 at the top.
minus- Yeah.
And then when you multiply it, you got negative 2x and a negative, 8. And when you subtract all of that, you end up with 0, because negative 2 minus negative 2 is 0. Negative 7 minus negative 8 will be a positive 1. So you've got a remainder of 1.
So it doesn't work.
It doesn't work, right, so not a factor. Right. Okay, so really, what mattered in all of this?
The remainder?
No, the lot.
In all of this big long, I'm gonna look at this one here right now because there's more to it. This one, there's plenty here, but I'm gonna go with the one on the right, B. I could have had any polynomial with x to the third, x squared, x, and then a constant term. What's the only thing that would change in any of these? Because I could give you a totally different equation. What's going to be different about it?
Well, the number.
What numbers? So like this number would be changed, right? Potentially?
Yeah.
Maybe if there's a number here or here and I'm including that positive part there, or here or here. So those are the numbers that actually matter, really, right? Because we know that they're going to have, like, if you get an x to the third, you're going to have to multiply by x squared to get back here, right? To get to x here, or sorry, x squared here, you're going to need an x term so that you get an x squared term down here, right? But it's the numbers we need to work out. That's what really changes, right? So some genius person came up with something called synthetic division.
Oh no.
What does synthetic mean?
Sounds very bad.
Opposite.
Not opposite. Think about like, not synthetic dash. What in general in life? What does synthetic mean? Synthetic oil, synthetic vitamins, synthetic leather.
It's real.
It is real or isn't real?
It's
Synthetic leather.
Fake.
Fake, right? You're not doing the actual thing.
So you get rid of like the X's or what?
Yeah,
Oh,
we do.
I was thinking
We do.
prosthetic.
Oh,
That's why I'm like, what?
that's
Io
funny.
has arms. No
Like
arms.
it is. It's like a fake arm, I guess
It's
you
like
could say.
X is a fake arm.
So this is a
What?
simplified
I
process
don't know.
where we omit all variables and exponents.
What are you left with?
Numbers.
Yeah. So first though, they give a rule here, and I want you to understand why first, because I don't like just giving a rule. Remember when we had something like this equals 0, like x plus 2, x minus 7, and I said what makes it 0? You would take each factor and say x plus 2, and you would set it equal to 0,
Yeah.
and you'd solve, and you'd say x equals negative 2. If x equals negative 2, this factor equals 0, right? The sign of the 2 changed, right? If I used this one, I don't have to go through this whole process here. You know,
But X
having
is.
x would be 7. If x is 7, this factor is 0. I'm showing all this because this next sentence of synthetic division has to do with this idea. The sign changed, right?
It only changed because you're solving for X.
I
though.
know, but synthetic division has to do with solving. We'll get there. Like you're gonna get like it's almost like you're looking at a whole lake at the moment, but we're gonna be simplifying down to like cups of water, eventually. What we're using synthetic division for. Right now, it's the big idea of synthetic division. So I want you to understand the concept of why what I'm about to write is coming from right here. When we solve, the sign of the number flips, right? So when we're doing synthetic division, it's a simplified process where we omit all variables and exponents. So by reversing the sign in the divisor, by reversing the sign in the divisor, remember that's the thing doing the dividing, you can add throughout. Yeah, I can't spell. The process instead of subtracting. But it also has to do with this. And this part, what I was explaining here, will make more sense as we continue on. Okay. Giving you a definition doesn't make a whole lot of sense until we actually do it. So let's try example 3. Use synthetic division. So we're going to say 3x to the third minus 4x squared plus 2x minus 1 divided by x plus 1.
So you put the X plus 1 on the outside of the thing.
Oh, you're doing that. Yeah, I'm only writing it as along, like, how we would write it, because I'm about to change it. So yeah, if you wanted to, Hannah wrote this x plus 1, and that's what's doing the dividing, and we would say...
You do not want to do that.
I'm going to, actually. X to the third minus 4x squared plus 2x minus 1, just to see like how we go from this setup to the synthetic division setup. So remember they said reverse the sign of the divisor, right? We didn't care about variables. If I scroll up here, it says we're omitting variables and exponents, right? What is it?
So does it mean take them out?
Hold on.
I know.
I know, you just want to jump way ahead. I'm not there. Nowhere near there. You'll figure it out in a second. Okay. So I'm going to reverse the sign and get rid of the x. I don't care about that.
So you should have -1.
Yes,
Okay.
-1, and we're going to change the way it looks so that we remember we're doing something a little different. That -1 kind of goes in the box to separate it. And I'm going to bring down every one of these coefficients.
But you
in the
don't
constant.
change their.
I'm not going to change their order, and I'm not going to bring down the variable or the exponent, just the coefficient.
Okay.
Because they're already in order, descending order. If they're not in descending order, you need to get them in descending order.
So 3
so that
minus
all
4
of the exponents are there and
plus
accounted
2
for.
minus 1.
So I'd have 3, -4, 2, and -1. Right. Those signs stay the same. Only the divisor flips the sign. Okay, so then I'm going to give myself this line because I'm going to do some work within. I'm going to highlight some squares. I'm going to make these squares and I'll write in them. Okay, there's one here. So we're going to be writing in these spaces here, okay, as well as below all that. Actually, I take it back. We're not going to be writing here. Did you figure it out what I was saying?
Why not under the 3?
Because we're just going to start with bringing the 3 down. Because remember when we did this division stuff up here, if, let's just say I had a 3 in here, right?
Mm-hmm.
The 3 would end up being brought down.
Cross it
It's
out.
what it has to be accounted for. So you would have a 3x squared up here if we needed
Okay.
that. I'm changing that problem entirely, but so for right now, all we do with this so far is we're just going to bring the 3 straight down. And then what we're going to do is we're going to multiply the -1 times the 3, and we're going to plop it up in that first green box. -1 times 3 is -3. Then we get to add.
Wait, where's your -3's coming?
Then we get to add and bring that down. So -4 plus 3 is
Isn't it negative?
-7. Yep. And I'm going to multiply again.
So -1 times 2.
-1 times -7. It's just gonna keep this flow. I'm gonna write with a
You're
highlighter.
skipping all the boxes.
Watch, you kind of. No. Watch. I'm gonna follow this pattern of this.
Oh.
Okay.
Oh, it's like that.
Yeah. Maybe I can just leave that there for now, and I'll clean it up after because I think you can see my writing over that. So I'm gonna take that -1 again and multiply it by the -7 that's been brought down, and follow the blue line, and it goes up to the green box. So that would be a positive 8. When you add 2 and 8, you get...
9. Oh, not
Wait,
2.
I'm sorry. I said 8. It's not 8. No, I gotta go back and
-4
change a
plus
bunch of
-3.
stuff. What?
-4 plus -3.
No, I'm saying -1 times -7 isn't 8. It's 7.
Wait, where is the -1 times?
This you still need as a -7.
-7
-1 times -7
is what you're saying.
is +7. It goes up to the next green box.
Yeah, right there.
2 plus 7 is 9.
9.
9 times -1 is
Negative.
-9, right? Add those two parts, you get -10. Guess what? Guess what 10 is?
A remainder.
It is. It's your remainder. And then we can take these numbers and put them back into a polynomial. Starting with it, I think it's easier to start on the right-hand side to say it's 9, it's positive, so I put plus. Going up the degrees, it would be -7x. I need to put the variable back in.
So
Wait,
you
where are
don't
you
do
getting?
x
Wait,
squared.
where? How do you have? Wait, so say that again. It's like
Okay,
it's
so
mirrored in
10 is my
fourth.
remainder. That's what's left over, right?
All right, 10 is
9 is your constant, so I'm going from right to left. I think it's just easier to not guess what power to start with.
How do you know it's not the -7 to start?
It-
I cannot see this backwards. Like I cannot flip things in my head like that.
Gotcha. So
back.
this is representing my polynomial.
Wait, 3,
If you
negative
recognize-
7, 9, negative 10.
Yep. If you recognize that 3 terms will give you a quadratic, then you can start at the beginning. But if you don't, start with the constant side. The last number before the 10 spot will be your constant. That's your 9. This one is going to be your first x term, the first degree x term, the linear part, negative 7x. This is a positive, so I don't have to write anything since it's the first one. 3, I need an x, but I'm not going to have another x. It will be the next degree up. It'll be x squared. You can check this if you want. You can do the actual division. You can set this one. Is it okay if I erase all this right now? Or how about this? I will.
Cut it.
Oh, wrong thing. Undo. Yeah, I will cut it. And I will put it on the clipboard. And then I will delete it so that I can get it back. So if I want to do the actual division up here to show what this all looks like, right?
Yeah.
I'm going to try and do it fast, so hang with me. I need to multiply x by, I need to multiply x by 3x squared in order to get this, when I multiply it to be 3x to the third. And then I'd have plus 3x squared, and I'm going to subtract all of that, and I'd end up with 0 there, and I would end up with negative 7x squared. Does that sound familiar, that negative 7? Didn't we have a negative 7 somewhere in that synthetic division stuff? So if I bring this over here, and I try and, undo, hold on. Let me get that back over here. And I can shrink it, and I can move it over here so we can pay attention. So I had a negative 7 in this, didn't I? Do you remember that? It's right here. There's that negative 7. So the synthetic division is doing all the work. It's just a little simpler. And then if I do that again, I say 3x, bring down the 2x plus 2x. I need to multiply x by negative 7x to get that back. So I'd have negative 7x squared, negative 7x. And if I subtract all of that, I'd end up with 0 in the first part. 2 minus negative, that's positive, 9x. Wait a minute, that sounds familiar too. I had a 9 somewhere.
But not a 9x.
Nope, but we looked only at the coefficients in synthetic division. There's the 9 right there. There's the 9. Right? If I keep going, I'm going to bring down the negative 1 then. I would need to multiply x by positive 9 in order to multiply it out and get it back. I did 9x plus 9. If I subtract all of that, these disappear. Negative 1 minus 9 is negative 10. That was my remainder. Right? All of these steps along the way are here, aren't they? All those and the coefficients is all that really mattered. So in the end, look at what's on top. 3x squared minus 7x plus 9. That's what we ended up with when we put the variables back in there. And we had a remainder of negative 10, right? So hopefully it's starting to make a little bit more sense.
Mm-hmm.
I don't know that I necessarily ever had a teacher that showed me these parallel to say, look, this is where those numbers are coming from. This is why it works. It's that multiplying step right here, and the subtracting part. We don't have to subtract because we changed the sign of the divisor up here. We just have to add then, which is kind of nice. And that's where you're adding to get this part on the bottom down here. We changed to yet another. This is where we were subtracting or adding in this one because we changed this sign. Right? We're going to try it again with a little bit of a twist in this one. Okay, ready?
Mm-hmm.
Okay. All right. Example 4. The volume in cubic feet of a sarcophagus, which is what? Do you know?
That thing on the left.
Which is what?
An Egyptian.
It's
It's
like
like-
a...
It's like a coffin.
Yeah, I
Yeah.
couldn't...
Okay, so the volume of the cubic feet of a sarcophagus, excluding the cover. So we're talking about a rectangular prism, basically, right? Something like this. Can be expressed as the product of three dimensions, right? Like length times width times height. But if we're not wanting to use all different variables, we would have x's all involved. So that the volume equals x to the third minus 13x plus 12. The length, I can't spell, is x plus 4. So part A is to find linear expressions with integer coefficients for the other dimensions. So we have an x to the third, which means we had something times something times something. 3 different directions, right? I have one of those directions, that's the x plus 4. We've never learned how to factor an x to the third, not never, but very few situations where we could factor x to the third. If we take out a factor, we factor it out, we're going to be left with something to the second, which we can factor, right? It's going to be a 2-step problem here where we're going to divide this x plus 4 into the volume equation to come up with what we have left for the quadratic or the area of, let's say, the base. So let's do the division. Let's do synthetic division, okay, for the sake of practice. So what am I going to write in this part of the box? I'm going to change colors even.
You're flipping the sign, so it's going to be -4.
Right. And then what are the coefficients that I need to write across?
-13.
Wait, what's in
+1?
Okay, so just a 1. That was the x to the third. So x to the third, I'm going to write a 1 in front of that. And then I had, wait a minute, what's missing in this equation?
The x to the square.
Oh.
X squared. So plus...
When we did this one up here, all of those were there, weren't they? I had a third, a squared, and a 1, and then a constant. But I don't in this one. How many x squares do I have?
0.
Oh, so I need to have that accounted for here.
+0.
I just need to have a 0. There's no pluses in there. It's just, they're just listed. So if I want to change this one, I can say plus 0x squared minus 13x plus 12. Now in the purple equation here, do I have all of the degrees on down to the constant?
Mm-hmm.
I have a third, a second, and a first, and a nothing, right? There is a constant. So I'm going to use those coefficients. So I'm going to have a minus 13 here and a positive 12. So what's the first step?
Bring down your 1.
Right. You don't have to write the arrow, I'm sorry. I'm just doing it. And then I do what?
I don't understand this ordering, but -4 times 0 then?
That's like the multiplying from the swoopy thing. That's like taking the thing up here and multiplying here and writing it down here. So you're multiplying, but we're going upward instead.
Wait, where does the line go?
Just give yourself a line in between so you can write numbers. Remember we had those green boxes there?
Mm-hmm.
-4 times 1 is -4. Add 0 and -4. Yeah, no.
I really cannot see this at all.
Just stay here. We don't have that much further. -4
So, negative
times 1 is
Oh, this one down
-4.
here
Yeah.
comes. Okay, so
Mhm.
it goes boom,
Mm-hmm.
boom.
So add 0 and 4. You get?
-4.
Right, -4. I'm not going to keep drawing arrows because it's going to get super messy if I do. -4 times -4.
Positive.
Mm-hmm. What's 4 times 4? Uh-huh, 16. She's writing it, not saying it for me. I add those two parts. -13 and 16.
-3.
And positive 3.
+3.
Positive 3 times -4 should be -12, I hope.
So then those cross out to be 0.
Right. So I don't have a remainder, which is good. So if I change these numbers here back into a polynomial, it ends up being a quadratic. It would be x squared minus 4x plus 3. Right? So that's the division. That's the answer to the division problem we just did. There's no remainder. We can factor this. So the part B of this says, if the length of the sarcophagus, oh, sorry, we didn't do that one yet. Now I'm not on B yet. Find the linear expressions. Do I have linear expressions here yet? Do I have linear expressions here yet?
No.
No, I don't. How do I make linear expressions?
Get rid of that.
By doing what?
Factoring.
Mm-hmm.
I already have that written.
Oh, good job. Okay, so we need to factor this into the two bubbles. Do you want to make a box or you just want to do it?
Just foil it.
No, we're not foiling. We're unfoiling, if you want to call it that.
Unfoiling it.
I need it to look like this.
Yeah, I'm gonna go with the box.
Okay, do the box thing. So I would have something like this, and I would put the x squared here and the 3 here, so I know that x and x are on each side. And I know that these two need to total a negative 4x. What multiplies to positive 3, but adds to negative 4?
Negative 1.
Negative 3, negative 1. I'd have negative x and negative 3x, and that would give me the negative 4 in between there. So my factors are the two sides. It's your x minus 3 and x minus 1. So now I have all of my factors, including what I originally divided by. So my volume, which was x to the third minus 13x plus 12, came from the length, x plus 4, times the width and the height, x minus 3, x minus 1. There's your three factors. Your length, your width, your height. Making a little bit more sense, I hope?
Yeah, I just wrote it out like that.
Like what?
Because you always go from the things.
I know, but the example said, find the linear factors. These are linear.
Yeah.
This is not linear. This is not, this is not linear. This is a quadratic right now.
Yeah.
Down here, I have it written as a product of linear factors.
Yeah.
Right. So it has to be done this way as far as that's what I'm looking for.
Okay.
Because then the next part, I'm going to leave this right there. Part B
Lily,
says,
you sit there.
it's a good question. If the length of the sarcophagus is 10 feet, what are the other two dimensions? In other words, find the length, width, and height, the actual length, width, and height. So length equals 10, width equals height equals, I don't really care which one of the expressions you're using for length and width, height. We knew that this one was your x plus 4, right?
For your 10?
Mm-hmm. So 10 equaled x plus 4. They said the actual length was 10. The expression was x plus 4. So what does x equal? You mean do the equation right?
Well,
minus
10
4.
equals
10 minus
10x 4. Yeah.
X plus 4 equals 10, so what does x equal?
So then you minus 4, which is 6.
Right. So x equals 6. Plug that into each of the other expressions. We have x minus 3. We have x minus 1. So put 6 in each of those. 6 minus 3 is
3.
3. 6 minus 1.
5.
Right. So we could say the length is 10, the width is 3, the height is 5. Then you could actually find the actual volume if you wanted to. So far, so good? Okay. Here's a really fun part that I like about synthetic division, especially if you don't have your graphing calculator around. It's something called the remainder theorem. If a polynomial let's say P of X of degree n is greater than or equal to 1. In other words, it's linear, quadratic, cubic, quartic, quintic, and so on. It could be any of those as long as it's above linear or greater. Is divided by x minus a, where a is a constant. No variables for that part. Then the remainder is P of A. It's as if you're taking this number, A, and plugging it into the polynomial, and you get some number, P of X. If you plug A in here, you're going to get some number. Like if I have f of, not 3, f of X equals x to the third plus 7x squared minus 10x plus 32. Totally making it up. I don't feel like plugging in f of 2 and doing all that math. But if I do synthetic division and use the 2 in here and all those coefficients, the remainder part will be f of 2.
Oh, makes sense.
That's what this box thing here is saying. The remainder will be f, or whatever polynomial function at which you're plugging in up here. Mm-hmm. Okay, should we try one? Sure. Not should we. We're going to, sorry. Example 5. Use synthetic division to find P of negative, I can't write, negative 4. Negative 4 for P of X equals x to the 4th minus 5x squared plus 4x plus 12. So I'm going to use P of the negative 4 here, and it's already in descending order. Do I have all of the degrees there?
No.
What am I missing?
X to the third.
So if it helps you, write it out, x to the 4th plus 0x to the 3rd, because it's not there, minus 5x squared plus 4x plus 12. Now I have all the coefficients that I need, here, 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 and here, right? So I can write it in as 1, 0, negative 5, 4, 12. Give yourself space, because you're going to write numbers below what you just wrote. Bring down your first number. And we're going to be filling in the green spots as well as the blue spots. And what's special about this last one here?
You already know the remainder.
Right. I don't already know the remainder, but it's going to equal P of negative 4. I know that much. That's what the remainder theorem says. So as soon as I do all these, fill in the green and the blue spots and get all the way to the end, the ending is going to be equal to P of negative 4. Let's get at it. Okay, so I brought down the 1. Negative 4 times 1 is?
Negative 4.
Add 0 and negative 4.
Negative 4.
Multiply. Negative 4 times negative 4.
16.
Positive 16. Good catch. Add those two. Negative 5 and 16.
11.
Multiply negative 4 times 11.
Negative 44.
Add those two parts.
Negative 40.
Negative 40, right? Multiply negative 4 times negative 40. I know it's going to be positive.
60.
Now add those.
172.
Right. So P of negative 4 equals 172. You can try it if you want and plug it into the calculator. Do you need to try another one like this just to see how it works?
These are kind of fun.
They are kind of fun. I like synthetic division, actually. Questions? That's the end of it.
This actually makes sense.
Yay! I like to hear that. Questions?
No.
Getting there?
Yeah, this whole thing where you go blah, 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 blah. It makes sense, but I just don't remember it.
You will. I promise you will.
Yeah.
Okay. Thanks for joining me.